In this video, we're going to talk through the worked out solutions to the final exam review number 2 for semester 1 of Algebra 1. So for number 1, it says consider the following function, and we want to find f of negative 4. And I know that when a negative 4 is inside the parentheses, that means negative 4 is the input or the x value. So I'm going to replace x with negative 4 and then simplify the expression. So on the right-hand side, negative 4 times a negative 4 is a positive 16. So I get 24. So the function whose input is negative 4, this function will have an output of 24. Over here, this is saying find x, meaning I don't know what x is, when the output is negative 10, or f of x is negative 10, or y is negative 10. So I put negative 10 in place of f of x, 8 minus 4x, and now I start solving for x because I want to find out what x is. I do inverse operation, so I subtract 8 because that's a positive 8. I have negative 18 is equal to negative 4x. The inverse of multiplying by negative 4 is dividing, so I'm going to divide both sides by negative 4. This would become a positive because a negative divided by a negative is positive. They're both divisible by 2, so this would be 9 halves. Now if I want to write that as a decimal, that would be equal to 4.5, or as a mixed number, 4 and 1/2. So any of those options would work. Let's go down to number 2. So as the scatter plot below models the cost of an airplane ticket versus the distance of the flight. So this is the equation that models the best fit line for the data. Describe the type of correlation. So type of correlation means that I could be talking about positive or negative. I could also be talking about the strength of it. So when I look at this, because these are trending upwards, I say that it would be a positive correlation. They're pretty close to line in a straight line. It doesn't give us the correlation coefficient, but I would say that this is a strong positive correlation. What does the slope mean in the situation? Well, the slope is 0.2, and let's remember that slope is our rise over run, our change in our y versus the change in x. So it's how the airfare is changing with respect to the distance changing. And it's positive, so we're increasing. So the airfare is going to be increasing as the distance increases, or more specifically, increases by 0.2. So it says it's in dollars. So how we're going to say this is that this is a trend, right? This is what we expect to happen. We use this to make predictions. So for each additional mile, because that's the distance in miles, traveled, we predict, because remember this is just using to make a prediction, we predict the cost of the airfare will increase by 0.2. Those units are dollars, so we'll do 0.2, and I'm going to do 0.20 because that's how we use or write money. We use 2 decimal places go into the penny. So for each additional mile traveled, we predict the cost of the airfare will increase, because we have this positive correlation, by $0.2 or 20 cents. What does the y-intercept mean in the situation? Well, here's your y-intercept. Remember, that's really 0, 100. It means the x-coordinate is 0. Well, if x is the distance, saying if you didn't travel any miles, the y, the airfare, will cost you $100. So if the distance traveled is 0 miles, in other words, if you don't travel anywhere, we predict the cost to be $100. Now, that doesn't really make sense, right? Because if you're not going to fly anywhere, then you wouldn't have to pay anything. But if we think about the context of the problem, then that might be, that $100 might be like your initial fee, or like just with their baseline cost, and then from there on, you end up paying more for each dollar, or each mile rather. So it doesn't really make sense to talk about if we don't travel any miles that we're still going to have to pay $100, but it could be that like baseline amount that as soon as you buy a flight, you're paying that. Alright, scooching down for number 3, for both A and B, it asks us to find slope. We talked about slope in the last video. Slope is our rate of change, our change in y over change in x, we have a formula for it. So let's look at it. If we give 2 points, we can do it a couple different ways. Some people like to make it into a table because we're more comfortable with tables. So if you do that, there's your x, there's your y, there's your other x, there's your other y. And we talked about in the last video where it's change in y, over change in x. So here I'm actually decreasing by 8. So my slope, if it's a change in y over change in x, we would get negative 1/4 as our slope. Now, some people also we have a formula that we kind of derived using this table notion that we did early in the semester, where slope is the change in y over the change in x, where you take your y2 minus y1 and x2 minus x1. So if you call this x1, y1, and this is x2, y2, and again, it doesn't matter which one you use as x1 or y1, x2, y2, because the order of these shouldn't matter. You should still get the same slope. We can say then that would be 9 minus 7 over negative 3 minus 5, which we'll see ends up being the exact same as when you made the table. So it's whatever you prefer to do. Now here we have a table, so I find it easiest to just find our rate of change. So here, subtract 8, subtract 8, subtract 8, and we see that this is consistent or constant rate of change. Add 4, add 4, add 4. All right, so now our slope would be the change in y over change in x, and remember f of x is just another way of saying y, so then that would be simplified to negative 2. Number 4 asks us to find the x and y intercepts, so I got to think through this. Everything I know about x and y intercepts. Well, on a graph, it's where the line or function, whatever it is, crosses the x-axis or the y-axis. But I also know that every point on the x-axis has a y-coordinate of 0, so x would be when y is 0. Your y-intercept is when x is 0, because every point on the x or on the y-axis has an x-coordinate of 0. So finding the x-intercept, I know it's going to be something comma 0, which means I can replace y with 0 and solve for x. Well, 8x minus 0 is just 8x. So we have 8x equals negative 14. I divide by 8. I get x is equal to negative 7 divided by 2, negative 7/4. Or if you want to make that into decimal, that would be negative 1 3/4. Well, that's a mixed number, but that would be negative 1.75. So that might be easier to understand where it would be on the graph. So we have negative 1.75. Now our y-intercept, we know it's when x is 0. So I could just take my equation and replace x with 0 and solve for y. Well, 0 minus 7y is just the same thing as negative 7y. And so then I divide by negative 7. I get y equals a positive 2. Because you know over here, keeping the same notion, our x-intercept is always when y is 0, or y-intercept is when x is 0. So for the x-intercept, I'm looking where y is 0, and I see y is 0 right here. So that would be my x-intercept. My y-intercept was when x is 0. I don't see an x equals 0 anywhere here, but if I look at, there's a pattern. Y is increasing at a constant rate, and x is increasing at a constant rate. And so I can use that constant rate to extend my table. If I work backwards, I would subtract 1 again, here, subtract 3, I get negative 15, subtract 3 again, negative 18. And now I have where x is 0, y is negative 18, and I've found my y-intercept. Flipping to the back, number 5 is asking us to write the equation of the line. So here I have this graph. And when I'm given a graph and I can see the y-intercept and the rest of the line, then I think I'm going to use slope-intercept form. The y-intercept here looks like to be 0, 6. And our slope, it looks like here's a nice point I can find the coordinates of here and here. So if I follow this, I'm going down 1, 2, 4, 5, right 1. Down 1, 2, 3, 4, 5, right 1. And same here. So that'd be down would be a negative 5, right 1. In other words, the slope would be negative 5 over 1, or just negative 5. My y-intercept is 0, 6, so plus 6. And there's your equation of the line. Again, you could use the graphing calculator to check to make sure that these tables would match up. Looking over here, write the equation of the line that goes through these 2 points. Well, we should have an and. Okay, so you have those 2 points. First thing we know we need is the slope. So we found that a couple different ways. I'm going to use the slope formula, y2 minus y1 over x2 minus x1. So that's 7 over 1, or just 7. So we know the slope is 7. We also need to find the y-intercept in order to write the equation of the line. Or when you look at this, you're thinking, well, I have 2 points and a slope. Maybe I don't jump to slope-intercept form. Maybe I go to point-slope form because I have a point and a slope. In that case, we either have y minus y1 equals the slope times x minus x1, So I can choose either one of these points. I'll just choose the smaller numbers. Y minus 2, because that's the y coordinate of that point, equals the slope times x minus 3. And now I could just leave it in point slope form because it doesn't tell me what form it wants the equation in. But if this final exam was multiple choice, if this were a multiple choice problem, I might need to convert it to slope intercept form. So if we want to do that, we can. If I distribute that, I get minus 21. I add 2, I get y equals 7x minus 19. And there you go. Now, it also might make sense to make a table, right? So if we have x and y, we were given 3, 2. We were also given 4, 9. We can find the slope here. We're increasing by 7 for y every time x increases by 1. So there you could find your slope. You didn't need the slope formula. And I could extend this table in order to find the y-intercept. So if I do 5, I add 7 again, that would be 16. 6, add 7 again, that would be 23. Now, this is not getting me closer to the y-intercept because remember, the y-intercept is when x is 0. So then if I work backwards, 2, that would be a negative 5. 1, I would get a negative 12. 0, subtract 7 again, I get negative 19. And there's your y-intercept. So if you like to use tables, that's another great way to do the problem. Moving down to number 6, we want to graph the function x equals negative 2. So I'm thinking about that. Gosh, it's not slope intercept form. We can't use the slope and y-intercept. But it's saying x is negative 2. So if I go to graph it, x is negative 2 right here. Now that's the point negative 2 comma 0. But let's plot another point that has an x coordinate of negative 2. Well, this would be negative 2 comma 1. This would be negative 2 comma 2. Down here, this would be negative 2 comma negative 4. And this is still, these are all the points where x is negative 2. It doesn't tell us anything about y. So what we end up getting is a vertical line where x is negative 2. Equation over number 7, it says, which equation below represents a line that is parallel to the graph of this, and which one would be perpendicular? Interesting. So parallel, remember, parallel would look like this. They're not intersecting, and when I'm thinking about that, I know that they have to have the same slope, and they have to have different y-intercepts. So let's first focus on parallel. The slope here is 9. Well, this slope is negative 9. That's not going to work. Negative 1/9. No, no. Okay, so now we have two equations whose slope is 9, but we need different y-intercept, and this one has the same y-intercept. So E would have the same slope and different y-intercepts. E would be parallel. Now perpendicular, remember that's where they intersect at a right angle. And for two lines to be perpendicular, we know that the slopes are opposite reciprocals of one another. And what that means, opposite are different signs. So if this is positive 9, the slope would have to be negative, which gets rid of these three. It's one of those two. Reciprocals meaning that the two numbers multiply to be 1, or in other words, you interchange the numerator and the denominator. So that would give me B here. So E was the correct answer for the top one, B was the correct answer for perpendicular. And there you go. Number 8, determine whether the relation is a function. Well, if it's a function, remember every input has exactly one output. We talked about the pop machine as another way to think through this one. So if it is a function, determine the domain and range. So first of all, is it a function? Well, when I look at this, each input is going to one output. You don't see two arrows coming from a single input. In other words, like this is like pressing the first button and getting Coke, pressing the second button and getting Coke again, getting Coke again. And we said that's okay. Sometimes we have these pop machines that have all of the same like it's all water, it's all Coke, it's all Gatorade, and that's still a functioning pop machine. So yes, because each input has exactly one output. In that case, the domain then would be all of the input values. This is a discrete function, so we're just going to list those values. And then our range would be all of the output values, in this case, just 0. Looking over here, is the function modeled by the graph linear? Well, if it's linear, our graph would be a straight line. I see almost like two linear functions together, making more of like a V-shaped graph. So I would say no, this is not linear. If you want to get more specific, you could say that this is a piecewise linear function because there's two pieces of linear. But we're going to study this next semester. This is actually going to be absolute value. So no, the graph is V-shaped, meaning it is not a line, and it would need to be just one line in order to be linear. Looking down here for number 10, it says solve the system of equations. We talked about this in the last video as well. Now, a system of equations we can solve 3 different ways: graphing, substitution, and elimination. But we're not going to solve by graphing. 1, we don't have a graph. 2, these are not in slope-intercept form, so they're going to be a little more difficult to graph. So we either do, substitution or elimination. Now, I look at these equations, I see both of them are in standard form where our x's and our y's and our equal sign lined up. So I'm going to go ahead and line that up, and I'm going to say that I want to use elimination. Now, when I'm looking at this, these 2 variables do not add to be 0. These 2 don't add to be 0, meaning neither of them eliminate right now. In order for them to eliminate, the coefficients have to be opposites. They need to add to be 0. So I'm trying to think, can I multiply -3 by anything to make it the opposite of 5? Well, no, because 3 or 5 is not a multiple of 3. And nor can I do that here. So now I have an option. I can multiply both equations by a number. So I see one's positive here, one's negative here. So I'm just going to go with my x's that I'm going to try to eliminate. So if I multiply the top equation by 3 and the bottom equation by -5, that will make the coefficients of my x variables opposites. I'll get a positive 15 and a negative 15. So negative 18 times 3, well, that would be negative 10 times 3 is negative 30. 8 times 3 is 24, so that would be negative 54. If I do that, that would be a, oh, I didn't want to multiply by -5. That would make that a positive. Scratch that. Let's make that a positive 5. There we go. Now we have a negative 15x, that's what I want, plus 35y equals 10 times 5 would be 50. 9 times 5 would be 45, so this would be 95. Or 20 times 5 is 100. One 5 less than that would be 95. So now when I add these, now I can see that the x's eliminate because their coefficients are opposites. I'm left with 41y equals 41. So when I divide by 41 to solve for y, I get y is equal to 1. I found y, but remember the solution to a system is an ordered pair x comma y, so I can substitute y equals 1 into either one of these. In this case, I'll just use the top one. It does not matter. I should get the same answer regardless. So 5x plus 2 equals negative 18. If I subtract 2 from both sides, 5x equals negative 20. Divide by 5, I get x equals negative 4. So my answer would be negative 4 comma 1. Now, I want to always check my answer, especially when if this is a multiple choice problem, because I'm not going to get partial credit for it. So if it satisfies, if the solution satisfies both equations, then I'm good to go. So do 5 times negative 4 plus 2 times 1, and when I press enter, I want that to equal negative 18, and it does. So now if I test the bottom one, negative 3 times negative 4 plus 7 times y was 1. When I press enter here, I want it to equal 19, and it does. So I've checked it, I'm good to go. And that is final exam review number 2.